Today we will see how we can solve the linear programming problem by graphical method. The question will be asked as solve the following linear programming problem using graphical method, and then it can be given either to maximize or to minimize. So here the question is maximize z is equal to 80x1 plus 120x2 subject to the constraints x1 plus x2 less than or equal to 9, x1 greater than or equal to 2, x2 greater than or equal to 3, and 20x1 plus 50x2 less than or equal to 360. So here we'll solve our first constraints, and for that we'll find the values of x1 and x2, which is x1 plus x2 is equal to 9. So if I take x1 as 0, then I'll get x2 as 9, and if I take x1 as 9, then we'll get x2 as 0. Then we'll find the values of x1 and x2 for the second constraint, which is 20x1 plus 50x2 is equal to 360. Here, if I take x2 as 0, then I'll get x1 as 18, and if x1 is 3, then x2 will be 6. So we got our points. Now I'll plot the x and y axis. And here we'll label the x-axis as x1 and y-axis as x2. And here, as we have found the points, we have the maximum value of x1 as 18 and for x2 it is 9. So I've done it like this: 2, 4, 6, 8, 10, 12, 14, 16 and 18. And here on the x2 I have taken it up to 12. Then I'll just plot the points. Our first point is 0, 9 and 9, 0. Then we'll join this using a straight line. So we have plotted our first constraint. Now we'll plot our second constraint. And for that the points are 18, 0 and 3, 6. 3, 6 comes on this line. Now we'll join these points using a straight line. Then we'll plot this x1 greater than or equal to 2. That is, x1 is equal to 2. And it will be a straight vertical line. And for x2 is equal to 3, we'll draw a horizontal line. Then our next thing is to label all these lines, which I am giving it as 1, 2, 3 and 4. And here 1 represents x1 plus x2 is equal to 9. Then 2 represents 20x1 plus 50x2 is equal to 360. Then 3 will represent x1 is equal to 2. And fourth is for x2 is equal to 3. The next thing we'll do is to find out the feasible region. That we'll be able to find from these signs, which is less than or equal to, greater than or equal to, and again less than or equal to. So as we know that the first line, it will be below because it is less than or equal to. Then it will be above the fourth line. It will be on the right side of the third line. And it will be below the second line. So I have shaded this region, and this will be my feasible region. Then after we'll find the corner points of this feasible regions and we'll label it as A, B, C, D. Now as we can see very much clearly that here x2 is 3 and here x1 is 2, which means that this point will be 2, 3. Then for B, this point will be 6, 3. and here this point is 3,6. We have already found that. Then we have to find the coordinates of the point D because it is not clearly visible from the graph. So to find that, we'll use this equation 20x1 plus 50x2 is equal to 360. And we already know that the vertical line is x1 is equal to 2. So we'll place 2 in place of x1 and we'll get the value of x2. Why we did this? Because for D, the two lines are number 2 and number 3. So that's why we found it like this. And here we have got it as 2, 6.4. The point B was clearly visible from the graph. If it is not visible, then you can find that by solving the equation 1. In that, you will place x2 is equal to 3 because the point B is at the intersection of the line 1 and 4. Then our next thing is to make a table like this: extreme point, coordinates, and value of objective function. Here our extreme points are A, B, C, D. These are the points of our visible region. And then write the coordinates like this. For A it is 2, 3, B 6, 3, C it is 3, 6, and for D it is 2, 6.4. Then the equation of the objective function is z is equal to 80x1 plus 120x2. We'll just place the values of x1 and x2 and find the value of the objective function. So for the first one, it will be 80 into 2 plus 120 into 3, which comes out to be 520. Then for the second one, 80 into 6 plus 120 into 3, it comes as 840. Then 80 into 3 plus 120 into 6, it is 960. And 80 into 2 plus 120 into 6.4. This comes out to be 928. Now our question was to maximize. We had to maximize the objective function. So we'll take the maximum value, which here is 960. Hence we have got our x1 and x2 and as well as the maximum value of z. So we'll write this as maximum value of the objective function is 960 and it occurs at the point C, which is 3, 6. That is, here my x1 will be equal to 3 and x2 will be equal to 6. So this is how you can solve the linear programming problem using the graphical method. And if you want my handwritten notes, then you can download that in PDF format from my website. You'll find the link in description. Thank you.